Out a square foot?
You know, it was loose this morning.
Oh, no, is that
So the
true?
negative
Yes.
charge.
That's why Ballard's making their own membrane then.
What's the Hamilton standard?
Not loose now,
Oh,
is
not
it?
loose now. Maybe that's why it's working.
Maybe we better leave it alone.
Miller's room's dress cheaper than that.
Huh?
Miller's got room dress cheaper than that.
Mr. Marshall went to
Bella has?
do assistant in here and holding that square.
$1 million.
Square
Roy,
on there.
you don't need to put that through the sodium hydroxide through the vinegar solution, do you? You're already purified.
See how it
I'm
runs
gonna
through.
take out any sodium.
And this is going to sit on the back of
So indirect, now you're indirect?
wood alcohol, impregnated paper. I'd back off a few pieces, Mr. Marsh.
Yes,
Figured a way to make the fuel cell that runs off
Not yet.
that. It's also, actually the fuel cell.
Roy, you sure you want to do a hard couple into there?
So it's just basically,
There you go.
you throw it away when you're done, or, no, you gotta,
Ah!
Squeeze it, I guess.
Whoa,
Whoa.
getting wet.
Look at that thing fly.
That's too many.
You don't want to send that liquid. Will that liquid spoil the fuel cell?
Oh, it's all right.
Is anything going on?
You're actually looking direct, aren't you?
this is a little, yeah, guy coming up with
Look for free energy.
cell for a cell phone. Basically, it powers a cell phone.
It didn't seem to make any difference whether it was down or not.
What's that?
The fan ran just as fast.
Is that a fuel cell?
Yeah, fuel cell that runs.
Does it
the,
run just as
Definitely
fast or
gone
not?
faster.
cellular phone.
Yeah, that's another thing that's gonna
Man,
come real
that thing
quick.
going on.
Replacing batteries,
Yeah.
disposable batteries, just put the fuel source on.
Right.
You're bypassing the solution, huh, Roy?
No, it's going through the solution.
Oh, what happens if you bypass the
I
solution?
see
Will it
they're
work?
using
Same.
camera.
This just cleans it up.
This guy's
Can I see that?
saying about the cam.
I read about
Yeah, you can
somebody had
already
a
buy them.
fuel, yeah, you
Yeah,
can already buy them
for
for
camcorders.
camcorders and, well, these big TV station.
Highway signs, we're using my highway signs.
What?
One of the
Fuel cells.
Left-handed
Yeah.
phone?
Fuel cells are simple in design, but they're
Yeah.
low on intensity.
Yeah, it just clamps right on the camera instead of the battery pack.
What do you got,
You
like a
just-
little
Which way
CO2?
you
You just have a little, yeah, you have a little hydrogen canister that you
Oh, it's just the opposite, huh?
stick into it. But what's nice because of the delay time in the fuel cell, you can keep running, you don't miss a frame, you can pull out the canister and stick a new one in and still be shooting.
What they do,
So you can change
can you
power
work it out?
sources
Is that what-
without stopping.
Now she's
which is
running a
nice.
lot better.
And what these guys do is they just have a big tank in the area where they're shooting. And they just take the little tanks to the big tank and charge them up and just slap them on the camera. These are professional, Betacam type systems and stuff. And they're already available now. You can buy those things. And that and road signs, portable generators, portable air conditioners, stuff that'll run power tools and remote applications.
Fuel cells.
Yeah, yeah.
50 watts.
Pressure's got to come down,
Yeah,
back down.
about 50 watts.
Pretty good size.
About this big,
Right.
the kit, but that includes the tank,
Raised up to
the
pressure.
tank built in it,
My
the fuel
brother-in-law was
cells,
Polish,
Does that still balance out and then
Is that
start
right?
bubbling
Are you
again?
Greek? Are you Greek?
No,
about
actually,
$2,300.
Huh?
We want to put in an advertisement, and I was reminded that that among the small companies, there are a number of companies that we would really like to make mention of, special mention of. And it starts with Urgenics. We haven't said anything about Urgenics. Urgenics in Wormwood, New Jersey, is a good company to request a catalog from and to buy hydrides from. Energy Partners, these are in the back of your green book, incidentally, The Philosopher Mechanic. But I want to highlight a couple of them, several of them, for fuel cell supplies. On 176, just after the glossary in the green book, I'll just tend to go through a roll call of these companies.
Okay, which one should we highlight?
Well, for instance, Urgenics is a good place to buy hydride supplies. If you have a hydride that you don't find anywhere else, they'll make it for you. But they also stock a number of hydrides. Another company that is a small company that'll accommodate a lot of special interest developments is Energy Partners.
What about this Electrochem? Do they have,
Electrochem is trying to put together a fuel cell, and you can check with them to see where they stand on it. But they'll do development work, certainly.
and to buy fuel cell material, which was number one would be DuPont?
Well, Deis.
Pardon me?
Deis Industries, D-A-I-S,
DAIS, okay.
is a good supplier of a new proton exchange membrane, polymer exchange membrane.
Okay.
It's a developmental membrane, and they'll also sell you an already made up solution that's a solvent-rich solution, so you can mix your activated carbon and catalyst if you want to put together your own system. If you think that your supply of hydrogen needs more catalyst, you may want to mix your own intermediate layer and put it on yourself. They will sell you the monomer in solution, so you can make that interface of material that takes the catalyst to where it really needs to be in contact with the electrode, the electron path, the catalyst, and the semi-permeable membrane. They're willing to sell that to you. Another company that is making polymer exchange membrane is Dow Chemical, and another one is DuPont. But Deis will work with you on customizing or giving you the materials for a customized fuel cell. Regarding the question that was brought up on hardware, you brought up the question of fittings and all that. Well, under tanks and fittings and systems on the next page, 178, Parker is widely distributed, and they're a good source. You can find a number of different divisions of Parker. You can find their instrument division, what have you. But go instead to their natural gas fitting division. Go to their natural gas fitting division, and you'll have a lower cost fitting that'll do more for you and being interchangeable to the natural gas industry.
For hydrogen?
For hydrogen, natural gas, landfill gas, producer gas, and even for propane.
So my regulators and everything I want?
Same.
Go talk to our natural gas division.
For a natural gas regulator company, pressure regulators, Go is a relatively small company, and they make them and they rate them specifically in their catalog for this various group of gases we just mentioned, including hydrogen. It's on page 179 under pressure regulators.
Which one?
Geo Incorporated.
What am I looking for? Hydrogen regulator?
Pressure regulator.
Pressure regulator.
Which one?
Pressure regulator.
Yeah, what?
Geo. Go. First one. Go Incorporated. On page 179, the right column, midway down.
I was looking for relief now.
There's a type of regulator you may want to use for tamper-proof operation. If you're going to leave your system exposed to the public, you may want to go to a TESCOM for a tamper-proof unit.
It's just at a fixed PSI. Just use pressure reducers, knock it down from high down to medium, then down to your.
They fit it so that you also have a water jacket on it. It's ready for wet supplies of gas or supplies that would make crystals in the expansion process where they cool themselves. So you can fit it with a hot water anti-freeze system so that it'll be very rugged, tamper-proof. Another comment is that in your system you want to pay attention to pressure relief devices, PRDs and pressure relief systems. And a good one to work with in that regard is Sherwood division of Harsco. I think that there's a worthy comment that could be made with respect to some other things that you may want to look into, and that's the safety aspect of sensing hydrogen before it reaches combustible limits. And you can do this by several different techniques, but DCH is making such a detector. It's used for the purpose of giving you alarms or shutoffs or something that sets you up for a safe result far before there's a combustible limit reached. And so watch DCH and Motorola, incidentally, for emerging technology in low-level hydrogen detection, or for that matter, low-level natural gas detection. I think that there's a worthy comment that could be made with respect to onboard hydrogen generators. And as it goes, two different technologies. One is with Larsen Radex. They make a type that conserves more of the energy units for your purposes because it's a endothermic reaction. It's using up waste heat from somewhere to deliver what you need. The other one that's listed here uses up some of the fuel potential, maybe 30% of the fuel potential, to make hydrogen. So there's two different schools of thought. The Larsen is the conservative one, the one that spends some of the energy to give you a special type of chemistry is the hydrogen burner technology product.
Problem with the phone number though for Larsen.
827-7915.
Where's Larsen?
It's on page 181.
What was the last four numbers?
7915.
They're using heat to get
They use heat to run an endothermic reaction to make hydrogen.
Hydrogen. That's AHAs. What type of unit is this now?
Well, it's a heat-consuming reactor that's different for each different fuel type that you'd feed it. But for landfill gas, it's one model. For natural gas, it adds another station, actually. But what it does is to perform the water-gas reaction to give you hydrogen. The water-gas reaction being basically some hydrocarbon.
And it uses any heat source.
Yep, it can use solar for stationary applications.
These are all, are these off-the-shelf units?
No, they're built to suit. And if you're in a solar-rich area, it'd be built to suit to make that type of application of heat. If you're a wind-rich area, it uses resistance heat. If you're in, whatever's appropriate for the renewable, you use that heat. And that's one reason they're customized to the location. If it's in a mobile application, you use waste heat off of the mobile prime mover. If it's a gas turbine, you use gas turbine waste energy. If it's a piston engine, you use water jacket and exhaust. If it's a fuel cell, depending on the temperature range of the fuel cell, you do what's appropriate.
Would this be something you could use to break down, say, horse manure into a usable gas?
You could. Yes, you could. This technology will work for that purpose.
Or she's heating? Would that be
I mean, in using, say, passive solar for your heating?
Well, it'd be passive solar, but probably tracking.
So you have a box that would track the sun, or either
Solar
a
dish.
reflector?
Or it would be trapping with multiple internal reflection to do the concentration.
And this would somehow separate the hydrogen out of the methane?
What this makes is carbon monoxide plus hydrogen. And in this case, you make 3 moles of hydrogen per mole of carbon monoxide. And then you go back to the comments on how to get rid of the carbon monoxide if you're running a PEM.
Right.
If you're running a phos acid, you wouldn't have to. You could run it. If you're running a carbonate, you wouldn't worry. You'd use it. If you're running a high temperature oxide electrolyte, use it as is.
But is it easily separated, or is this just a mixture of both carbon monoxide and hydrogen?
It's a mixture and doesn't like to be separate.
Okay.
So you need a reformer or something to get it.
Yeah. Well, this would be, it depends on what you start with and where you're going, what temperature of fuel cell you're applying it to, what degree you change it. The other company that I'd like to make a reference to and make a recommendation of regarding supplies and equipment that you're going to need goes back to the fitting comment, the fittings and whatnot. There's a need that goes hand in hand with making the chemical correction for your purposes, and that's to make the particulate correction. Within the fitting category, you need to incorporate some filters. You need a charge filter so you get out the big things. So anything you're loading on board, you sift out the straw and rocks and anything big. You'd like to have it also knock out the water. Usually you want to get rid of water in your incoming fuel. And then after you've processed to whatever degree you do, whether you're doing a change of the molecular nature, changing the constituents or not, you probably want to go to a final filter before it goes into your fuel cell. It's always hard to get things back that have gone into that cell. So you'd like to use a final filter, which means that you'll probably need, for fuel cell work, you'll need a high pressure entry filter and a low pressure final filter. You'd probably like to have a high pressure capacity in your entry or your first filter, and you only need to have low pressure in your final filter. But in that low pressure final filter, you'd like to finely filter to a much finer particle size. So Boston is recommended. They're an outfit that has packaged for this purpose and will understand what you're asking for when you go for primary and final filters, and for special Innes filters. I wanted to solicit reviews, observations and reviews, and more questions. But I'd really like to hear from you in the time, with respect to the time we have available, how to deliver what it is that you came to find in this course. What are we missing? What do we need to do to satisfy your needs? Who has a compelling need that we need to handle in the remaining hour? Dale Gates.
Yes, sir.
What's your compelling need?
I need a car so I can get a computer.
Okay. All right. Yeah. Right. D.K. Harrison. What's your compelling need?
Put it all together.
Okay. All right. All right.
Could I take off on that?
Please.
You know, this is kind of like fuel cell 101. Maybe we need fuel cell 201.
No question. Let me put in a plug. All this does is scratch the surface and try to skim over a bunch of topics, some of which you want to pick up on. Absolutely. Ordinarily, every one of these fuel cells that we've mentioned will take a semester. Every one of them deserves a semester. When you get into high temperature fuel cells, you get into a class of materials that's worth a semester of material science. Maybe more. Medium temperature really takes some challenging chemistry to master.
And I said it was simple.
Well, but Jerry's right.
You know you. Yeah, I know.
But at least you've heard some of the terms. You've become aware of how to test to see what they're trying to tell you in terms of efficiency, for instance. In terms of what is a fuel cell? Is it a place you put gasoline or a electrochemical device, and so forth. Yeah, I think that's a very important observation.
I guess I would like to see a whole bunch of parts on a table. You know, some Nafion here and some nickel mesh here and some plastic there. You know, you put it all together. You know, plug some hydrogen into it, see if it works or it doesn't, and why doesn't it work. And actually to build some fuel cells.
I don't mind taking this one apart and putting it back together now that it has gone through its first round. You can see that. You can do that. You're welcome to. It's just that, mind you this one's been together, it's got dents for all of the components, and it'll be hard to seal it afterwards. But other than that, you're welcome to.
Well, I just think that would be a really good way to understand this, is to just build one up from scratch out of just pieces.
You're absolutely welcome to unravel this one. But I would say again, and this is important, if you're going to do that, and it's going to be PEM technology, you have to greatly overload the platinum by that approach. By the time we did it in open air around a group of people on casual approaches, it would lose a lot to be desired in terms of catalyst.
So you're saying these usually need to be done under controlled laboratory type conditions?
Oh, one fussy person needs to keep track of it and get it right.
I think it would be interesting to see the annular spaces, to see how
Oh.
the hydrogen it.
Yeah, you're welcome to take it apart. And
Do we do it now?
sure. Yeah, if you want to spend the time on that,
Take it apart.
if you want to spend the time on that in that regard, well, it's okay.
Go ahead, Charlie. I'm curious.
The reason for building it out of transparent material is to let you see the most that you can possibly see without having put it together by layers.
That was very helpful. In fact,
Yeah.
I wanted at the beginning, that way we have more of an idea what's going on.
Well,
But, you know, the transparency of that is. that's very
Yeah.
helpful.
So we can still,
Walter, what's your compelling need?
there's still enough energy in there, look.
It's hard to single one out.
Okay, well, here it is, Jack. They've got it now. They've got a machine that runs on its own.
There's the perpetual motion.
Walter, what do you suppose is going to happen to his car when he wants to put on the brakes? He's done it now. He's through the stoplight already.
Yeah, he
Flywheel is kicked in.
Yeah, right.
Why is this happening? Just residual hydrogen in the...
For an hour.
Well, that's what I was talking about.
No.
What kind of...
A few minutes.
What he has
I
to
heard that this fuel cell didn't have that ability.
do is put a switch in the external circuit. If he's going to make this thing behave, he's got to add a switch.
Well, you're going to have to purge it.
No, he's going to put a switch in. He'll pretty soon he'll figure out he can master those electrons faster than anything.
Are you done in that lab?
Yeah.
I'm going to close it out.
Okay. What he's going to realize is that he can put much faster control in the external circuit than he can internally.
That's amazing.
You gotta nip that wire.
Well, yeah, you can.
You might have a hard time reattaching without a switch.
True enough.
I would go back to you asked me. I'm kind of like the last person there. I believe to some degree it would have a little more if we could cut materials and actually
Nowhere on that side.
construct the unit, the fuel cell. I mean, that's what this is, a fuel cell for. If we could just actually have all the different units, like even this air aluminum deal, you know, you had to put it together in itself, maybe, I don't know.
Keep the moisture.
But that,
You just have one membrane that showed the manufacturing of that one.
or if you just
Gene-
had pieces out here.
Gene, do you want to see some? Is that what you want to see as a membrane? I'll go get you some membrane, if that's what you want in there to see. What he's about to discover is that once you get that catalyst disturbed or bothered, it's going to be hard to unscramble the egg that you've dropped.
You can't drop that egg.
You can't drop that egg and put it back together very well, unless you get it. Yeah,
So we're going to see membrane there.
Yeah.
There's a reason for using plastic.